Hey guys, it's Teddy here, and today we will be solving the problem check if n and its double exist. So what this problem basically says is we'll be given an input array and we have to check if from that input array if any of the element has its double present within the same array. For example, we have been given with two examples here. Let us look at the first example 10, 2, 5 and 3. In this example we can see that the double of 5, 10 exist within the same array. That is, we have to return true if for any one of the element in the array a double exists within the same array. We have been given example here 3, 1, 7, 11. Now within this example you can see that the result is false because for any of the elements in the array their double does not exist. The double of 3 is 6, the double of 2 is 1 is 2, 14 and 22. None of them exist within this array, so hence we are returning false. So how do we solve this? So I'll be solving this problem from the very basic level. So if you're someone intermediate, you can just skip to the most optimized solution, and if you are an advanced guy, I don't think you would be watching my channel. So let's begin with the very basic approach. What's the very basic approach? Right now, what did I tell you? We have to check the double of each number, right? So we are calculating the double of 3, which is 6, the double of 1, which is 2, the double of 7, which is 14, the double of 11, which was 22. So if I write it quickly just over here, 3, 1, 7, 11, and the double of each of these were 6, 2, 14, 22. Now we can just calculate the double of each of this element and look for it within the original array, right? If this is suppose the array twice which we are calculating and this is the original array, so what we can do is check if 6 exists in any one of these positions, right? If it exists here, 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 here. No, it does not. Okay, let's move on to 2. Here, 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 here. No, it does not. Similarly for 14, no, it does not. Similarly for 22, it does not exist. However, if you consider the first example, which was 10, 2, 5, 3, the double of each of these elements would be something like this: 24, 10, 6. Now for 20, let us check. 20 does not exist in this array. 4 does not exist in this array. However, 10 exists here. So in this case we can return true. So how do we code this up? Well, if you observe, what we had been doing was basically take each element and compare it with every position in the original array. So if I just quickly write down the indexes here, this was 0, 1, 2, 3 and 0, 1, 2, 3. So for 0 we were checking at every position 0, 1, 2, 3. For 1 we were checking at every position 1, 2, 3. For 2 we were checking at every position 1, 2, 3. For 3 we were checking at every position 1, 2, 3. So if I can consider this as I, can I say all of these values will be j, and we will need two nested for loops, one which will control the value of I and another which will control the value of j. You know how nested loops work, right? So what I can do basically is, if I quickly write down the pseudocode, it will be something like this: for int I equal to 0, I less than n is the size of the array, I plus plus, and inside this loop we will be having a j variable which will iterate through every possible elements. So j less than I, j plus plus, and if if twice of I equal to ARR of j, return true. That should be it, right? But no, there's a problem here. There's a slight edge case which we need to consider. Now this edge case might not come up in your mind in the first try, but as you practice more problems it will come up in your mind eventually. So what is the edge case which we need to consider here? Let us take the following example. Let, let us consider an example here which is 1 0 3 5. Alright, now the double of these elements will be 2 0 6 10, right? Now for 1 there does not exist a 2. For 0 there exists a 0, but it is the same 0 at this position. There does not exist any other 0. The double of 0 is 0, but this is the original 0 we are talking about. There does not exist a duplicate 0 which we can call as the double. So what we need to consider basically is, if we start comparing this array elements with this array elements, right? So if we consider every position, here it won't return true, but in this case if we start from here it will not return true. But when these two positions match, it will see 0 is equal to 0, so it will return true. So this is a slight edge case you need to consider, because this is the original 0. There is no duplicate 0 in this original array which we can consider it to be the double of 0. So we need to consider this slight edge case and need to modify our code. And the slight modification would be something like this. As we observed, here at position 1 and here at the position 1, it was the same 0, right? So if the position of I and j are the same, we will not consider that element, we won't check it. So the modification will be something like and I not equal to 0. In that case we will just skip, right? So this is a slight modification I was talking about. And elsewise what we can just do is return false, right? So let's just quickly code this up and see what's the result. So here's the solution. What we need is a double array, right? An array which will store the double of each element. So you know how to iterate in a vector, right? So what we can just do is store the size of the array in a variable. Let's call it n, and we need to consider another vector which will store the double. Let us call it twice, and now we need to store the twice of each element in the twice vector, right? So let's iterate through the original vector I equal to 0, I less than n, I plus plus, and what we can basically do is twice dot push back 2 into ARR of I. So it will store the double of each element in the twice vector. Now what we can do is check. So I equal to 0, I less than n, I plus plus, and iterate through the original vector. So j equal to 0, j less than n, j plus plus, and now our if block, if twice of I equal to ARR of j and I not equal to j, then we can return true. Else what we can just do is return false. Let us quickly submit it. And we can see it's getting accepted. But can we optimize this slightly? Because what we are basically doing here is consuming an extra space of big O of n, right? So can we somehow neglect this big O of n space? I think we can. Instead of storing the double in a vector, what we can do is at every step, in this case, at every step, you can just compute the double and check if it exists in the array, right? Right? So what I'll be doing basically here is, instead of this, I'll be removing this twice vector, and this twice of I was basically the double of the current element, right? So what I can basically do is, if 2 into ARR of I, right? If 2 into ARR of I equal to ARR of j and I not equal to j, return true. Let's quickly go ahead and submit this. And that's getting accepted as well. So don't care about this runtime complexity, it does not matter. So we optimized that extra space which we consumed. Now this was the simple brute force, the simplest naive thing that can come to anyone's mind. Can we maybe somehow further optimize it? Because what this basically is doing is consuming a big O of n square time, because we are learning two loops for checking, right? So can we optimize this? We can. What we can do is basically use a set or a hash map, and let's look at the solution now. How can we optimize this using a set? So what we'll be doing now is basically study how to solve it using the optimized approach, that is by using a set. Now something to remember about set is it stores elements in a sorted fashion, and one more thing, it does not store duplicates. Please remember this about set, because it will be helpful in the future when you solve more problems and it requires set. So how do we solve it? Let us consider this example: 2, 5, 3 and 10, right? So what we'll be basically doing is, for every element, check if the double or half of the element exists within the set. Why half, you may ask? Let me show you here. For 10 we can say 20 is the double and 5 is the half. Now the double of 5 is 10. We can also say the half of 10 is 5, right? So if the double or the half exists within the set, we can say will return true, right? But one thing you need to keep in mind is, while checking the half, you need to check if it is completely divisible by 2. What do you mean by completely divisible by 2? For example, 10 by 2, it's 5 and 5 exists, right? But if I change this 10 to say 11, 11 by 2 will also return 5, right? But in this case the remainder will be 1. So what we can do is, we can basically check if num divided by 2 exists and num modulo 2, that is the remainder, is 0. Only then we return true, right? So let's just look how we'll be solving this problem. So it was 10, let me change it to 10. So let us take a set. Initially we push 10 because it's empty, right? So now we check if 5 or 20 exist within the set. It does not. We go ahead, we insert 2. So 4 or 1 exist. It does not. So we go ahead, we insert 5. So 5. So 10 or 2, does it exist within the set? It does. 10 exists, but 2 will not be considered because it is not completely divisible. 5 is not completely divisible by 2. We'll get 2 and a remainder 1. So In this case 10 exists within the set, so what we can do is return true. Now how do you code this up? It's quite simple if you know how to use set in C++. So the code will be something like this: for int I equal to 0, I less than n, I plus plus. We are basically iterating over the original array. Now we can go ahead, and what we can basically do is check if the half or the double exists within the set, right? So maybe I'll do something like this: int d equal to arr of I modulo multiplied by 2, and h equal to arr of I divided by 2, right? So I can check if it exists within the set, right? So if s dot find d not equal to s dot end, this is basically how you find within a set. Or maybe half exists, so s dot find half not equal to s dot end, and we need to check if this is completely divisible, and arr of I modulo 2 equal to 0. In this case we'll return true. Otherwise what we'll be doing is we'll be adding the element within the set. So s dot insert arr of I. Else what we can do is, if it does not find any element, we will return false. That's how you do it. So let's just quickly code this up and check if our solution works. So let us quickly code this up, and let us declare a set of the type integer. Now we will iterate through every element in the original array. I equal to 0, I less than arr dot size, and I plus plus. Now what we were doing is basically store the double, so arr of I 2, store the half, which was arr of I by 2. Now we were checking if it exists within the set, so if s dot find d not equal to s dot end, or s dot find, we also need to check if either one of the double or half exists within the sets, right? So s dot find h not equal to s dot end, and we also need to check, this is the mandatory condition, if it is completely divisible by 2, right? So arr of I modulo 2 equal to 0, right? So in this case what we are doing is returning true, and we need to add the element in the set. So s dot insert arr of I. Alright, now elsewise what we are basically doing is just returning false. So let's quickly submit this, and I think it should work fine if I just submit this. Yeah, it's getting accepted. So this is basically how you solve the problem. So thanks for watching.